Okay, so now it should be, the audio should also go to the stream. So, okay, that's good. So we can start. Thank you for your answers on the test. I will check them most likely this week, at the end of this week, so we can discuss the results next week. Yeah, so this is about this test. We'll discuss the answer then most likely on Monday. Okay, so this is about the test, and today we're going to continue talking about, mostly today, we'll talk about the collections, and as I promised, we will take a look on some types of collections, see what the differences are, and how to use them. So first, we remember what the collections are. Simply, the idea is, let's see, okay, let's see. Mother just sent a test, okay. Yeah, regarding the, okay, it was just zoomed in. Yeah, regarding the collections, remember that the collections are the objects where we can put the, which can represent many other objects inside, like the box of the box where we can place our items, or any kind of items. We can declare the variant that the option that all these items inside this box will have one type. Then we use generics, or they can be any type. Then we do not use generics. Yeah, mostly we do use generics. That means that all the objects, all the items inside the collection, they should have the same type. Yeah? So this is why we use generics to be able to define it, and then that each collection will only have exact type defined on the creation. Yeah, so same as we do for generics. Every time we so when we use the type, yeah, basically remember, generic, it means generics for the classes. It means that we basically create the template type, and in fact, this would mean that for each particular type, there's different class. Yeah, so we can, okay, maybe technically it's not like really different ones, but like if we look on it straightforward, then we can say that we actually have different classes. Yeah, so let's say if type is integer, then we have one class, and if type is string, it's another class, and so on and so on. So for all the different objects, there's different class. Yeah, because actually the template types, they affect the methods. Yeah, basically they say what each method takes as the input, yeah, and also what it returns as the input. So basically, for each type, in fact, the logic may be different. Yeah, the class may be different. That's why we can simply say that the class, also the type, is different for each type. Yeah, for each template type we apply. And so for this particular object, again, this would be integer. For this object, for this variable, yeah, that would be string, and then the object would be generic with, and the type would be integer, and then the type would be string, and so on and so on. Yeah. So basically, we declare we have different types. Yeah, and this is what we do for the collections. Yeah, when we use generics, we provide the type, and then the collection should have one exact the items with one exact type. Remember that the inheritance and the rules of casting can also be applied here. So it means that if you say that generic list have let's say one class, yeah, the type would be the class. Then it can also then we can also assign the objects. We can add the objects which are typed as the subclass of the particular class defined under the collection. Yeah, so it means that if the class is declared here, then we can also add the subtypes of this type to the collection. Yeah, so remember that the rules of casting, they can also be applied here. Yeah, so same rules as for the casting. Yeah, and basically we use collections to wrap the items inside the one box of, let's say, inside one box of items, but there is one point what we discussed today, and what I mentioned last time is that the way how the technical way how we implement these items, it can be different. How we implement these collections, it can be different. Yeah, because technically, okay, we all started with the arrays. We all know what the arrays are. We know how the arrays look like, how they work, yeah, how they implemented, how we can work with them. So for the arrays, everything is fine, but remember that we have limited functionality with the arrays. Yeah, we cannot basically, the main problem with the arrays is that they cannot be extended. Yeah, like if we define the one exact array with the size, let's say 6, then we cannot add the 7th item to this array. It's not possible. We need to declare a new array. Yeah, so, and yeah, this would be the problem for the array. But again, as the option would be that, as I just said, that we create a new array and increase the size of the new array. But remember that the problem is that we need to create new object. That's first. Secondly, we need to add. We need to copy all the elements from the previous array and then paste them to the new array we create. Yeah, so that these would be heavy operations, especially when we work with the large number of items. So let's say we have the array which has, let's say, thousands of elements, and then let's say you want to add one element to this array, then it means that you need to create a new array with the size 1001 and copy. Yeah, you must copy all the elements from the array, from the previous source array, which has thousands of elements. You need to copy them all into the target array and then add one element again. So then again, yeah, as you may understand, this may take some time, technical time, yeah, for the program to execute it, and also from the memory perspective, this won't be good as well. Yeah, so yeah, we have different implementations of the array, or of the collections. Yeah, we can store also the functionality. Yeah, as I just said, we can add a new element, we can remove the element, and then so in that case, that would be that if we add new element at the end, then it will be placed at the last position. Yeah, we can add it at the exact position we want. So there are different options, and there may be other collection types, other representations of the collections. Like we all know the stack, how the stack for the queue works. So the implementation there would be that we have the implementation like the real stack. Yeah, like we can add the new element, so this will be on the top, and then if we remove the element, it will remove the last element added. So this would be, so for the QS and stacks, the representation would be for the first in, first out technology, and first in, last out technology for the stack. So yeah, the representations may be different, and also the idea of the collections may be different, and we can explore them all. And yeah, so last time also discussed the iterators. So the iterators are needed for the collections to be able to go through the elements. Yeah, so we all know that for the arrays, that this is the main point, that we need to go through all the elements there. And for the collections, that's the same. We need to have the way how we go through how we go through the elements. Yeah, we can have some primitive options, but for the array, for the collections, we usually have the implementation in the way that it is done same in C#. It's done the same way as for the arrays. Here we have this option for each, which will allow us to iterate through the elements. This is why the iterators are important. And last time we checked how it is possible to do it with our own collection. So if we do, maybe not only with the collection, but with any class we want, we implement. So we can we need to implement the interface IEnumerable. This interface gives us several methods. Yeah, and the key method here is what we must implement is get enumerator, which actually implements the iteration. Yeah, so for this implementation, we need to use this interesting syntax. Like we simply implement the iteration through the elements, and then for each element we use yield and return. And so this is such interesting construction you need to use to implement if you want to implement the iterator. Yeah. But then the usage of this would be the same as for the arrays. Yeah, we use for each, and then that would be for each the object which is created based on persons in this case. Yeah. We have the object array persons, which is created from the persons, and then we can iterate through this object this way. Yeah. So using this syntax, we can achieve it. Yeah, and then we have the collections. Collections. This is simply the framework used in C#, and the framework is actually based on the interfaces, implementations, and operations. And yeah, as we discussed last time, it's quite a good question from Irina that, if I'm not mistaken, it was from Irina that the collections are. It's not like there's one exact type of the collections. Collections just the description of the. Yeah, we can say that this is the description of the data type. Yeah, and yeah, actually, there's no such type like collections. It's only the interface which represents the classes which are the collections. Yeah, so collections can be array lists with like some different stacks, queues, tables, and so on and so on. But collection is just a simple representation of them. Yeah, so there is no such type like collection we can use. Yeah, we need to use the class which implements the collection, and maybe I can also show you one quick picture. Yeah, there are different pictures. Let me take a look on. Yeah, I think you can check each of them. It's not really. Yeah, maybe let's take a look on this one. That won't be one moment. I mean, this one. They're the same, I guess. So this would look this way. Yeah. So for the collections, you can find the hierarchy, how they are implemented. So on the top of the hierarchy, we have IEnumerable. One moment. Okay, is this really correct? One moment, I guess. Yeah. So just one moment. IEnumerable. Oh no, I guess yeah, that is correct. Yeah. No, hold on. Oh no, yeah, this is correct. Yeah, I was still a little bit confused. Yeah, this is correct. Here. This is correct. Yeah. Yeah, because coaction input, it also extends INumerable. And so basically on the top we have INumerable, but yeah, we can barely say that this is on top, because basically what this means that iCoaction, it contains INumerable interface. Yeah, so INumerable means that this is something. Yeah, remember what the interface means. Yeah, remember we talked about the interface and what is the idea of the interface. I mentioned that for the interfaces we have such option that there are marked interfaces, and I would say that if you understand the meaning of marked interfaces, I would say that this would be the key description for the interfaces. Yeah, because marked interfaces means that, yeah, remember, maybe I will show you one example just for you to remember what are the marked interfaces. Because I would say that this may really help if you understand what they are. So a moment. This would be, we discussed this, but I think that would be good if we take a look on them again, because if you understand them, you can easily understand what the interfaces are in general. Yeah, so if you understand what are the marked interfaces, then I think you can easily understand the key point of the interfaces. Just one here. The solution. Good. Yeah, the first day of December. Winter's coming. It's already there. So I see. So yeah, the marked interfaces. Basically, if I say we have the interface and we say marker, and just any marker, any description, what we can add to the class here. So that would be, let's say, iComputer. Yeah, so again, we can have some description here, but let's say that I have the class, let's say smartphone, for example, smartphone, and then I say that this would be computer. Yeah, or I say the class yeah, or let's say a class PC maybe, yeah, and then that would be also iComputer. Yeah, so basically using the interfaces, I can mark that this particular class, it is like what's the interface mean. Yeah, so, or description of the interface. So we can describe the class in some way using the interfaces. Yeah, and usually for the marked interfaces, it is simply possible that they have nothing inside, so they look like this. So this is for marked interface. Yeah, they look like this, so they have no logic inside. They just simply are the interfaces. What we can, because again, remember that for one particular class, we can, I mean, not only class but also the after class or another interface. We can place several interfaces. Yeah, so it means that I can assign iComputer. Also, I can assign iTechnology, for example, or something else. Yeah, so for one class, remember, I can assign multiple interfaces. Yeah, I can assign only one superclass, but I can assign multiple interfaces. Yeah, and interfaces, as I just said, they can be marked interfaces, and they mostly, I mean, in general, the interfaces are also mostly used to add some descriptions to the class in this way. Well, like in this case, I say the class is computer, and the class is PC, and using the interface, I add such description that it is computer. Yeah, so this is the main thing how we can look on the interfaces. Yeah, at first we can say that they are they provide some special descriptions to the class. Why they are needed? Simply because, yeah, first of all, we can add some methods here. Yes, so it must be void power on, for example. And we can have some methods, so it means that each class should implement these methods we add here. And so, yeah, so this is the first is the functionality. They should have in common all these classes. And on the other hand, I can, yeah, so maybe let's implement, maybe, okay, I will not implement them now, but what I can say that if I create the object, I can always check if the corresponding object is computer, for example. Yeah, so then I can do such check using the interface. Okay? So yeah, this will be one of the options that, and most of we consider the interfaces as, yeah, again, so we can add some logic, and in addition we can add some descriptions, but at top we should look at them as the descriptors that they describe the classes. Okay, is this clear for you? Are there any questions?
Yeah, hello. I have a small question. It's a little bit unrelated. I was just looking to the first method. What is this main? What is default in a console write line? This one. Question is, does this method compulsory needs to be included in every console write line project we are creating?
No. As I mean, if you want to run your program, you need it, because this is the runner program. Yeah, basically,
okay.
This is the method which will start your program if you run it from console.
It makes sense. Yeah. Okay. Thank you.
And this is actually only from console, because from the web applications they are started. For example, web applications are started differently. Some other applications there can also be started differently. If you have the class library, it simply means that your library will be used somewhere in other application. Yeah, that's why it's not mandatory that this is there. But if you want to run your program, you need to have static void main, and yeah, it also means that if you have several classes, so let's say another class 2, and you have static void main here as well, then if you want to run the program, it will not understand what you want to run. Where is this one? Yeah, so it will not understand. And it says the program has more than one entry point. That's why I cannot run this program. Yeah, so you see this error here. The console program cannot be compiled because of this. So this is the runner. This is the runner, but again, if your class is not used as the runner, then you can. Yeah, it's already over. And yeah, by the way, I guess we need to rebuild the program, otherwise it will not. Yeah, basically the compiler understands this error only after I build the program. And before I build it, it will not understand. Okay, so this is about, in general, again, about the interfaces. And if you understand that the interfaces are mostly used to describe the class or describe another interface, we can go next and take a look on the IEnumerable. So it again, the interfaces, they can contain the methods, and this one does contain. And yeah, then we simply, like, if we look on this way, then we say that I collection, it has the description IEnumerable, so it means that all the collections, they are enumerable. Yeah, and one more thing, remember the interfaces are usually named using I then the name. Yeah? So if you see I, it means that this is the interface in C#. So yeah, we have I collection and I collections. They are all enumerable. So it means that we should be able to iterate through the collections. Yeah. And then yeah, so we have two types of the interfaces, the lists and the dictionaries. Yeah, and then you can see what are the classes which implement these two types. Yeah, so we have the type list, and it is implemented by array list and array. Also linked list should be there, and then we have dictionary. So this is list, dictionary, hash table, and sorted list. So these are different. We'll talk about them a little bit later. And also there are separate types, yeah, which are not lists or dictionaries. These are queues, stacks, and bit array. So these are also different types which implement collection, but they are not lists or dictionary classes. Yeah, so maybe I can copy this picture and share it here. Yeah, so you can take a look how the hierarchy of collections look like. Okay, and then we see the core interfaces. Yeah, so I collection, and there can be also read-only collection. We'll mostly focus on simple collection. Then I compare means that it can compare two objects. Yeah, I dictionary, what we just talked about, the type of the collections. I enumerable means that it can yeah, it supports simple iterational collection, and yeah, basically enumerator, it is the top on the top of the enumerable list. It's just what we just discussed. So yeah, and then what are the operations we have on the collections? So we can check if the object exists in the collection. So these are the usual operations we have. So it means that we have the collection, the box of items, yeah, we can mention it this way, and then check if one particular object, we can use the value of the object, or like if we talk about reference value types, then we can check if the actual reference, like we have the address of the object, then we can check by address if this particular object exists in the collection. Remember that if we compare two objects, then the reference is checked of two objects and not the values they have. So let's say we have one object which has the attribute, one exact attribute, and like two objects have the same values, it does not mean that two objects are equal. Yeah, we can implement the method comparable, and only after that you can implement the logic you want. But by default, if two objects are not comparable, then the program can only check their references. So it means that the search in the collection is also done using the references. Okay, so then we can retrieve the object from the collection. So it also depends on the collection type and on the way you retrieve. So you can retrieve, let's say, for example, the first object entered or the last object. Yeah, you can also get the object by index. You can provide the index and get the object. You can add the object to the collection. And the new one, you can also, there can be different ways you can add it. You can add it at the end, at the beginning, in the middle, or at any position. Or, yeah, last time we also discussed add after. So a moment, this would then look this way. Yeah, last time. So I'm confused about it, but yeah. So let's say we have the list, for example. No, collection generic. Yeah, let's use generics. And let's say I use linked list. for example, yeah, maybe let's use linked list at this point. And let's say I have the linked list of smartphones. I create the linked list, and then we had yeah, so when we add let's say add last, you see that there is the returning type, and the returning type is, yeah, like you can simply execute the method without getting anything back from here, but you can get the linked list node. So that would be this node, let's say that would be the node of smartphone, and then I can get it from this method. Fantastic. What was this? Okay. I of course need to the node. Okay. So, and yeah, this will be the special reference which represents the position of the element in the linked list. And then if I, let's say I want to create a new smartphone, for example, and then add it to the collection, then I can call the method list add after or add before. So this means, and here I can provide the node. Yeah, and I can provide the element I want to add. So this would mean add the elements sp2 to the list after after node yeah, after, yeah, maybe that would be correct, after sp node. Yeah, so here I add sp, it returns the node. Yeah, this is the special object which points to the position where it is, actually to the place where sp element is added. So I get the node, and this points to this particular position where node is added. Yeah, and then I can add a new element, and then I can add after, and I provide this node, and it means that it will add it after sp2. Yeah, so I can also do the following thing. I can add before. So this would mean that I add before this node. Okay. So add before and add after means that I add after a particular node. Okay. So after a particular element. Okay, is it clear? And this one. Okay, you see, I missed that. Okay, and before you can type the questions. Yeah, ask me. I mean, if you want, yeah, so that's the good question. Basically, why, yeah, so the question here may be, why do we actually need to use node? Why we cannot say, we cannot do, let's say, add after sp2, for example. Sorry, sp1, sp2, yeah. So why we cannot say, please add us sp2 after sp1? Why we can't do this for lists and linked lists? So this may be the question, and the answer is simple, because let's say that I add sp object twice. I can do this. So it's not prohibited for the collections, and then what we see. So maybe let's quickly do a moment. We have list, and do one moment. Yeah, let's maybe use this these formed expressions. So we can use system link, and I think we can use one of the expressions here. And it was O, yeah, if I'm not mistaken, O. Yeah, that's me. And console. That one. Okay, oh, a moment, okay, and what was the okay, sorry, that was not okay, I think we can use select if I'm not mistaken. Yeah, I think we can use select. And oh no, a moment. So with these found expressions, moments. No moment. Yeah. So about the printing, let me quickly. For each, I guess there should be for each. A moment. Each. Yeah. Sorry. I was searching for each, but there's each. Yeah. Yeah. I was searching for each, and yeah, there's actually each. A moment. There's no each. Moment. So I was so a bit confused why there's no for each. Oh. Or there is for each. No. Why there's no for each? One moment, I'm not a bit confused. Okay, I can use for each separately. But can I do one expression here? Okay, I think, yeah, maybe for this. Yeah, maybe for this that was not possible. Oh no, hold on. I think I can do it for array. Okay, moment. If we check, I can convert to array. No, I still don't have for each. Comments. Okay, then the moment array. Yeah. Okay. So okay, yeah, that was for array. Yeah, sorry, just I was a little bit confused here. Okay, yeah. So let's use this one, and then yeah, then here I provide still the array. List to array. So this is just an alternative instead of using for each. And then the action would be that I print all the elements there. Console write one x. Okay, so now, yeah, so just in case you want to use one of the expressions, on the expression to print the elements of the array. Yeah, if you want, you can use also for each simple, but yeah, that would be the alternative. Just if you want to do everything in one line. Yeah, and let's see how this would look like. Yeah, okay, the representation is, yeah, I'm sorry, yeah, the representation now looks strange. But yeah, the thing is, again, we can count the number of the objects we have. One moment. Okay, we have 4 objects, so it means that we add 1, 2, 3, and 4. Yeah. So basically, we see that we have duplicates here. So we can have duplicates here, and basically for the lists, for linked lists, it is not checked if the object already exists in the collection. So answering to your question, Elena, we must use note here, because otherwise the program will not understand which particular element you are talking about. Yeah, so like if we don't use note, the program will not understand where you want to place the element, because we may have duplicated elements inside the collection. That's why we need to use note. But this is for the linked list. Yeah, this is for the linked list because the reason is that it can have duplicates. We will see next that there are the collections where there are no duplicates, and for such collection, like there is no difference. But yeah, for the node, the point is again, node it is the object. It is the object, so it has the reference. And yeah, so let's say that yeah, just imagine the collection. And so what happens here when you say please add the element after one particular place? So if we use node, then it directly sees the reference to the node, so it can quickly search for the position, because the node can already points to the position. But if you use another element, so in theory it would also need to then search for this element. So, and the searching usually means like if the collection is not sorted or not hashed, then also the search requires more time. So node, it has the reference, so it directly points to the exact place we are looking for. So this is technically more efficient. There is one overload. Let's check out what was the overload here. Advanced. Okay, one. Oh no, sorry, not advanced. Add after. And after we have 2 overloads. The first one is that we add node and value, and the second one is okay. And then it's also possible that we add a new node, one node after another node. And so then that will be possible. And yeah, so that would be. And yeah, so here remember we have 4 elements, but so here we can also get a new node here as the result. So let's say that would be, or maybe let's try one more thing. We can try to add last element, and here I can add the node. And so then I try to add another node, and I mean the node which is already there. So let's see what happens next. And we get the exception. Yeah, so yeah, we get the exception. So it means that the node should be unique. Yeah, so this is the point. The linked list node already belongs to the linked list. So in case we try to add the node to the list, it may trigger the exception if the node already exists. Yeah, so basically the thing is that the node should be unique for the linked list. The nodes should be unique, but the elements themselves can be can be not unique. So, and in this particular case, I think we can start talking about the representation. Basically, yeah, not yesterday, but on Monday you asked the question about what the difference is between, let's say, list and linked list. And actually, we can take a look on them, on the differences, by implementing them by ourselves. So let's quickly, not quickly, but let's implement the linked list, our own linked list. How this would look like. So basically, what the linked lists are. Maybe let's. Yeah, I think it's better. Maybe let's first finish the topics before the linked list, and then we okay, maybe let's go back. Yeah, maybe let's start with the lists, and then let's we can go back to general topics on the function. So basically, what the linked lists are. So those who worked with me before in the previous course, we discussed this topic, but that would be fine if we can discuss it before. So as I just said, for different collections, there is the different ways how these collections are created. Again, one way would be that we use the arrays, and this is similar to what you already worked with. I mean, with the array store. Remember, you had the array store, which is pretty much the same as the similar as the implementation of the array list of the lists. But yeah, there are some differences. We will also talk about it today. But the key point here is that on the base on the lists, it is the array. Yeah, so the elements under the lists are stored the same way as you've seen it in as you've done it in the array store class. Yeah, one moment, I'll maybe quickly open this array store class. So maybe just to not open one more Visual Studio window, I'll just simply then maybe open it in Notepad++. So we use this, if I'm not mistaken, activity 4, right? Yeah. So we had array store. Let's open it. Okay, it is here. Yeah, so for the array store, maybe let's better use the open the abstract class. So that was better. Again, I'm opening Notepad++ just because it's not open anymore Visual Studio. And yeah, so basically we store the elements under the array store. Yeah, array store is the class. Yeah, that's the object we use, and all the elements we add there, they are all stored under the array. Yeah, so basically, despite the fact that we have our own class, our own objects, they still, all the elements are still located and stored inside the array. Yeah, so this is relevant for such collection types like lists and array lists. Yeah, so the elements there are stored under the array, but it's not the only way how we can implement the list collection. Yeah, so using the arrays, it's not the only way how we can do it. Yeah, so actually we can also have another way, and this way is more tricky, but it does not require to create any arrays. And this is a linked list, and for the linked list, the key point is that, let's say we have one object, And basically one object has, basically there are two types of linked lists. There are singly list links, or we can say one-way linked list, or two-way linked list, or doubly. Moment, let me quickly check. Doubly, or how? Yeah, that doubly linked list. Yeah, so, or we can say two-way linked list, or one-way or singly linked list. So a singly linked list, what does it mean? It means that simply, again, as I told you last time, it means that one object has the link to the next object. Then the next object has the link to the next object. So basically, they are not stored inside the array, but they have the link to the next object. Yeah, and using these links, they basically create the list. Yeah, so I can say that this is the first element, this is the second element, third, fourth, and if the element does not have the link to the next element, it means that this is the last element. Yeah. And these are the single linked lists. Yeah, so it means that singly means that they have no link to the previous elements, but in C# we have double linked list. It means that each element from the previous each element has the link to the previous element. Yeah, so if the element has no link to the previous element, then it means that it is the first element. Yeah. So these are the linked lists. So do you understand? Is it clear for you what the linked lists are? We'll talk about the implementation of them now, but about the general concept, is it clear for you? I mean, how they, yeah. Okay, for Alien it's good. How about others?
Yes, it looks okay. Thank you.
Okay, that's good. So yeah, this is the way, and you see the structure in, I would say, lots of maybe all the main programming languages you may work with. And let's have a quick look. Let's implement. Let's create our own linked list. So, what's the key problem is for the linked list? The key problem for the linked list is that for, let's say, if I have any class, yeah, so let's say class smartphone, by default it does not have the pointer, the element where I can store the pointer to the next element. Yeah, so again, if I take any class, you see that, or if I take the superclass, it does not have the place where I can store the element, the member where I can store the pointer to the next object in the collection. What can be the solution? The solution could be that we have one additional class, which in this case I think we can call it node. So this would be, we can say that would be node. And so we can say node has also template type. And so what we can do, we can say we have public t previous, and so it has getter, and all the setter. Okay, maybe first let's define setter as public, and then we can change it to private if needed. And then the next one, previous, and then t next. Let's say we also use getter and setter. Yeah, so we have one additional, let's say, helper class. Yeah, the class which helps us to implement the linked list. Oh yeah, and I can also say the current one. I guess the current one should also be fine. That. And okay, for setter, yeah, I think maybe let's not use setters. Oh no, I guess the setters may be needed, but only as the private. can all define these setters as the private. That would be a better approach here. And let's say that I defined a constructor. So the constructor would be, let's say, public node, and yeah, here I can provide the elements. So the elements would be previous, and that would be next and current. Oh no, I guess for the next I guess we can set it as the public, because yeah, normally we add the previous next elements after the object is created. Yeah, this makes sense. Yeah, because again, we usually add the elements to the collection one by one, and it means that when we add the element to the collection, the node is created at the point when the element is added to the collection. The next element after the current element we add is not known. And that's why it should only be added later. But the previous one should already be, we should already know it. That's why we can set them. So we can set the previous, but we cannot change it after that. It's the current one. Yeah, the current one should also be not changeable. This also makes sense. Okay, so and then yeah, okay, we can do that. Yeah, and let's implement the linked list. So let's say we have our own linked list. Again, I will maybe not implement the collection interface because at this point I just want to simply, or maybe let's say my linked list here, just to not make any confusion here. So just not, yeah, because you see, if you have the same type defined locally, then you need to use system collection and blah blah blah, system collection generic. Then just you need to use the full name to be able to use the previously defined, the generically defined linked list. So that's why maybe I will use my linked list, so just to not make confusion between this linked list and this one. Yeah, so then it is defined here, and yeah, and basically what we can do here we can we can add the nodes. One moment. So yeah, basically what I need to do here, I can let me think. I guess there are several ways. I can start with the first element, and I can enter the last element. One moment. Let me quickly think about it. Yeah, because we need to store at least the last element, at least one element. So maybe let's store the first element. Private t, that be first element. Yeah, because we know we need to have the pointer to at least one element. And yeah, in this case, I don't really need to store the exact element. I need to store the node. Yeah, so then that would be public nodes t, and this would be, say, first element. Yeah, I can start with the first element, and then I can set. Sorry, I can. Do I need a constructor? No, I don't need. No, if not, I can set as null, or you can simply keep it as is. should be no difference. And yeah, basically let's implement some methods. So the first one would be public void add yeah, let's say add last or add elements. Again, it's up to you. And then I can say that I want to add the elements t, and then basically what happens if the first element is null, yeah, so it means that the collection actually is simply empty. Then I can then what I can do, I can create the node t, sorry, then I can create, I guess, the first element, yeah. Sorry, then I can create the first element. Then I create the first element, and then the previous would be null, since this is the first element, and the current one would be element. Yeah. This is strange. Why I can convert from null to t. This is really strange. Let's hold on. Yeah, I have an idea. What I can do, we can also then do the following way. We can only add the current. Okay, that would be fine. That would be fine, and yeah, then I use this constructor. Yeah, so in this case, I overrode the constructor, and in this case, I can have the option when I provide only the current one without previous. Yeah, because in this case, when I add the first element, there's no previous element, right? And so there's this picture. So just for you to understand. Yeah, so see that for the first element, we don't have previous, going to the previous one. Yeah? That's why we keep it as it is. Okay, maybe right now let's have 10 minutes break. So just everyone can have a rest, and then we can meet at 7:45. Okay, so let's have 10 minutes break now. Okay, we can continue. Yeah, so for the case when we have first element, then we can create the node which does not have the previous element, yeah, which yes makes sense. And then let's say if we have, okay, I think since I have one statement, I can have can skip using the brackets, but then I have a case else, and what happens for this particular case? For this particular case, that would be simple. It means that for the first element, I can add the next element. So the next element would be the element we currently want to add. And then for the current element, wait, sorry, that won't be correct. That won't be correct. Okay, maybe let's add the last element as well, because that would be easier to deal with. Last element. Also say it is no. So, and then if the first element is null, then I can assign the first element, and then I can also say that the last element would be the first element. Yeah, so this will be the case when I have only one element in the collection. Yeah, so it makes sense. If there's one element in the collection, then the first element would be the last one as well, right? So then I say that the last one is the first one, since they are the same. The first element. Sorry. Okay. Yeah, maybe in this case I cannot add the same nodes, but I don't know. I mean, this would be fine. So since technically I can do whatever I want here. Yeah. So then the first element will be the last element, since I have only one element in the collection. Yeah. So, but let's say if I add the second, the third, or further element, then I can say that the last element for the next one would be next, and would be the element I currently add. Then when I say that the previous element for the next moment is this, okay, the T. There's one thing I don't really like, and that will be the type. Yeah, because we deal with the nodes. Yeah, so that would be correct. Yeah, that was incorrect since I used T here. I need to use the nodes. I need to use the nodes instead. Yeah, because we work with the nodes. Yeah, that's why I need to use it here. And then, so here when I add the current element, the current one. One moment. Let me think. Okay. Oh no. Sorry. One moment. One moment. Okay, then the current one, yeah. So the current one would be T, because the current one should simply represent the object I'm currently in. So that's why the current would be simply T without any node. Okay, so now it should be better. And then I store it. Yeah, then I say for the last elements, the next would be elements added. Okay, maybe I will do it the following way. I will then create the subject on the top. So that would be node T. So it would be elements node. I created here and then I can add it here as the first element, and this will also be the last element. Or I can add it, and then, so in case if I already have the first element, then the next would be, the next for the last element would be the new element node we have here. So then the previous for the element node would be the last node we have here. And what I do, and then there is one interesting thing. Then the last element would be the element node. Yeah. Previous. Oh, nothing on. Hold on. Okay, then maybe let's do the following way. I will then, yeah, so maybe that wasn't right. I'll define it this way. Yeah, that would be better. I'll do this way, and then here I can provide the information that then I can use this constructor for the previous and the current one. Yeah, so that would be the previous and the current one. Then I can skip using previous. Yeah, so okay, then I add the previous and the current one, the current elements and the previous node. And then the next one for the last element, the currently last element would be the node I currently create. And then the last element, I replace it with the current one. And here it is important to follow the sequence. Yeah, because I cannot add this at the top, this would be incorrect. Yeah, because again, remember, this is the variable, and under the variable there is the reference to the object stored. Yeah, so in this case, I do all the operations with the last element as with the object, and then I replace this last element at the end. Yeah, so this should be done at the end once I completed all the operations with the previous element. Because in this case, yeah, at the end of this method, the last element will be replaced, but the previous element will it will be used as the previous for the current element, and it will also store the reference to the next element. Yeah. So yeah. So this will be the point. And basically, yeah. So I mean, in theory, we could also have the case. I guess maybe there are the implementations where the last element is not provided, so we simply use the first element. Such case also can be done, but then I need to yeah, so maybe we can also quickly do it. For example, I can have the method get last. So that would be node t get last. Get last. And then I can do the following thing. I can so then if I say if this first element is null, then I return nothing. Then I return nothing else. So if the first element is not null, then what I can do, I can do the following thing. I can define node t gets current element. And then I say this first. And then I can do while loop. So then I say while current element next not equals to. So remember, for the last element there is no next element. While it is not null, I do the following thing. I assign the next element to the current element. And then at the end I can return current element. Yeah. So this would be the way how I can get the last element without storing the last element. So in theory, right now I could then comment this code. I can comment this code, and I can comment then basically here. Then I can get the last element this way. So last element with this get last elements, and then I can pass this last element here. Then again, then do the same operation here. Yeah, so that would be another option how we can store, how we can basically get the last element. Yeah, so we need to basically not. So in this case, what does it mean? It means that we get the reference of the first element, then we navigate through all this list, and then we get the last element. That would be the option. Yeah, but as you can see, this is maybe not really efficient because we need to spend time to go through all these elements. Yeah, so maybe for this particular case, I will uncomment this logic, but for you to understand that it's not mandatory that we have this last element stored for our linked list. Yeah, so it's not mandatory because we can get the last element using the first element. This is basically the point of the linked list. So is this point clear? And that's the last element is not mandatory, but as I just said, is recommended due to the performance reasons and memory reasons. So, okay, hope it's clear. If not, then please ask the questions. So yeah, then we can add the elements, and yeah, we can add the elements. We can add the elements, and so then let's say what we can do. We can get the element by index. A public t get elements by index, for example. And then we can provide the index here. And and then what I can do, I can go through all the elements and find them by index. So that would mean that I get I define integer I equals 1. Oh, sorry. Yeah, that would be correct. And then what do I do? So then I do the following thing. Get the element, so bt. Sorry, no, I'll get node. T could be element. So I start with the first one. And then I say while I is less than index, and and element has next. Yeah, basically next. Or maybe we can implement the method has next. So that will be public boolean has next, and here we can simply return this next equals no. If it equals no, then we return false, else we return true. So then we can check if while index is I is less than index and element has next. Yeah, in theory, I can also define it using getter, for example. Okay, so if I define it using the getter, then that would be the following way. And so in theory, I can define it as public elements here again. And what's the problem? What's the problem here? Not all called. No, the return the value. Okay, sorry, I need to get, I need to use, so I forgot to use return. So it's fine, here I get to return, and now I can simply check if the element has next. Then I basically do the same, I increment index, and I get the element. So an element equals element next. So I can do the following thing. And then I return the element at the end. Hold on. No, then that will be the following thing. If index is less than index, and if element has next equals false, then I return empty. I simply return null. It means that the index provided is greater than the number of the elements. And default t. Hold on, default t. Okay, so that would be that would be the option. Or I can raise the exception. Then the index out of bounds. And at the end, I can convert element, and then I get the current one. Okay. So because remember that the element itself is the node, and the current one is the elements t stored under this node. So let's quickly check. I is less than if I is less than index. Okay, else it goes deeper. It's incremented, and then we get the next element. Okay, this looks correct. So we can get the element by index. We can also get size. In theory, I can store the size here. So that would simply be integer size equals 0, and then when I enter the element, I'll simply say that this size be incremented. So maybe I can also do this. Oh no, maybe let's store it this way. It doesn't really matter. So then if I want to get size, again, it's not mandatory to store the size. I can again go through all the elements of the linked list and count the size. But I guess again that would be better if we store the size that way. So then we int get size, and then I return the size we have. This size. Yeah, that would be correct as well. Okay, those at last. Okay, let's maybe try it. Let's maybe try it. I will maybe comment out this one. And then let's say I create the linked list, my linked list. This was type, let's say that will be string. Yeah, I can use any type we want. Be my list. Let's say I create new. As you see, I don't provide the size of the collection because it's not needed. And let's say I add some elements. And maybe let's only use that last. So let's say here is my text. Then I also add last here. So maybe text 2 or something like that. Let's also add maybe 2 more elements. Let's say maybe name or just random text here. Yes. Something like that. Yeah, just some random text here. Okay, so we have all these elements. And yeah, let's maybe also implement the iterator. Implement our numerator. That would be t. Or maybe iNumerable. Be better. So that would be t, and I need to implement. Get the numerator. Let's implement it. Or not the numerator, maybe let's try numerator. Okay, no, maybe let's just simply use enumerable. It will be faster. And then I need to implement the method get enumerator. The type is iNumerable. Or sorry, what was the type? Just a moment. iNumerator, okay. iNumerator, then the type. Okay, iNumerator, okay. Type T, and then that would be get enumerator, right? Get enumerator. and yeah, get enumerator. And then yeah, so here maybe I cannot really use for each. Yeah, but what I can do instead, so let me take this one to me. So here I can do maybe differently. I can do the following thing. I can try. Yeah, let's try. So I'll get node. That would be the elements. And I'll start with the first one. So maybe a moment if yeah, so first we need to check if oh no, hold on, okay, before, okay. So I have the element first, and then while element is not null, I can do the following thing. I can yield return element, and oh no, so yeah, elements to current. Yeah. I return elements current, and then I go to the next one, and then I say the element equals elements next. Yeah, so and every time it will return next one, and at the end I will break. Okay, let's see how this works. I guess I messed up. Numerable. Get the numerator. One moment, let me quickly check what was the. I'll get the numerator, just one. Have I implemented that? Hold on. Okay. And okay, then I need to implement simple enumerator. And okay, and that would be simple without the type. Then what I can do, I can simply return this get enumerator. Moment. Huh. Okay. Okay, so the problem is that it wants me the type to be there to commit to it. And let's return it null. I know it does not like it. Oh no, hold on. Enumerator. Okay. It will be enumerable. And okay, moment. Okay, this looks a little bit strange. Okay, so it wants me to press don't have much in return type. Not implement because it does not have much in return type of I enumerator. Yeah, but I mean I don't have to type. Well, how did I do it last time? So a moment. We did it last time. Okay, it was enumerable. Okay. Okay. A moment, yeah. So then that would be okay, my mistake, sorry. My mistake. Maybe let's keep using the template type here. Okay, we can do this without template type. Okay. So we can do it without the template type. Or no, we can provide a template. Sorry. No, we can skip them using template type. How did I do this last time? Okay, I had this enumerator. That was fine, and then I returned it. That was fine last time. So what's wrong this time? No, I had this here last time. Okay, I'm saying. What's the problem? What's the difference here? This looks strange. Supports implementation using generic type requires one. I don't use this generic type here. Let's try to rebuild it. It looks very strange. This is the same as I had last time. So there are no difference. This is enumerable, and we got this. We got this using enumerable. What are the differences? So strange. Can you spot the difference? We have enumerator here, enumerable interface here, and then I do the same here. And now it wants me to system collection generic. Hold on, and this is system collection. It's not generic. Okay. Okay, I think I got this. Yeah, this is actually quite crazy, but okay. Yeah. So the point here is that this is different class. This is actually different class. So collections, and then I use enumerable. Okay. And then I need to get okay, so here I use the numerator. No. Hold on. Here also use numerator. One moment, what's the problem? Face get numerator. No, it does implement this interface. Okay, so then same here. Sorry. Yeah, actually this is really good points that for you to understand. Yeah, so now everything is fine. Because let's reload it, and all the errors should disappear. Because actually it used different class than I used before. That was the issue. Here you can see you can place your cursor at enumerable, and you see that it implements system collections enumerable. interface, but here it implements system collections generic, enumerable, and there was the issue here. Yeah, so then I need to provide the full name to place on the right one. We can also do it with the generics, but at this point let's simply stick to this one. Okay, so let's see if this actually works. Let's try to implement for each, and then that would be, I can use element var in my list. And then let's try to print all the elements. Let's see if this works. Okay, let's see. Okay, all the elements are printed. Yeah, I'm a little bit surprised that it happened from the first attempt. Yeah, so here is the thing. We can use the iterator. We can iterate not only on the arrays, but also on the linked list or any other collection types. And here you see, I don't use the arrays. So basically, everything what I do here, I implement using the links, using the nodes. So let's try to maybe get console right line and say I want to get my index. So let's say I want to get the third element. Let's see what the result would be. What I will buy, is this correct? 3, 1, 2, 3, 4. Yeah, this is correct. So I can, then it means that I can also use this as the array and add new element. So, and we have add. Let's say we want to remove past. Say remove. What? Remove last, maybe. So what this would mean? This would mean that I need to. So the last element then in this case would be the previous one. And so it means that this would be the previous one. And then, so for the current last element, next would be no. It would be empty. That would be it, I guess, right? So let's see the result. Let's see the result. What will happen if I remove the last element? Let's check if it works. Yeah, you see that the last element is removed. So if I do it twice, then it should be then removed twice. And oh, one moment. Then of course I need to change the size. I need to decrement the size, of course. If I use the size, then of course I need to decrement it. Otherwise, that won't be correct. Okay, see that I removed it. And we have the correction result, the last two elements. Okay, so what else we can do? Let's say I want to add somewhere in between. So then let's say maybe, let's say public void at add, and here I can provide the index. So that would be integer index. So if, so for example, I can again work with the exceptions, but maybe at this point I can maybe skip doing this. So then if index is greater than the size, then maybe I do nothing. Again, normally we can do the exceptions, but in this case, maybe let's skip using the exceptions. Yeah. So, but yes, let's keep using the exceptions at this point. But normally we need to do this. Like if the index exceeds the size, then we better throw the exception. Yeah, maybe I'll write a comment here. At this point, it's not maybe so important, but let's say I want to add it at the index, and basically, what does it mean? It means that, like, let's say I want to add it somewhere in the middle. So, yeah, so let's say I want to add it somewhere in the middle. So it means that I need to rearrange, not rearrange, but do some changes there. And what are the changes needed? So firstly, I need to get the element by index. So maybe if the size equals 0, then I can simply add the element at first position and return. Yeah, so that would be the exceptional case. So that means that first element would be oh no, hold on, I need to create node. No, sorry, I can create node here. So that would be nodes, the elements. Yeah, of course, I add the index, and of course I need to know the element I want to add. So that I say I add the element. Oh, so elements node. That would be more correct. And then again, I say the first element is the element node, and then the last element is also the element node. Yeah. So that would be just such exceptional case. Else, so if size is not 0, then it means that we need to else size is not 0, then we need to put this element somewhere inside the collection. So, and this may be actually the tricky case. So, what do we need to do here? In this case, I need to get the element by index. So then firstly that would be get element by index. So maybe let's start with get node by index. That would be maybe what we need more. Get node by index. And then I can simply copy paste this logic here and then return the element, and then here I can call this element get node by index, and then return current. Yeah, so why? Because I need to I have the logic where I need to get node, and that's why I can have double methods. With one of them gets the element and another one gets the node. Get element by index is public, so since I can call it from other class, and this one is private because I only want to use that inside my current class. So, and then I get node. So let's say the node index. Then I get the element by get node by index. So this would be the index, and it should not normally be null, because in this case I know that the size is not 0, and the index is less than the size. So one moment. Index is 0. Okay, yeah, then if the index is 0, then then if the index is 0, then I can add it to the first position. Okay, so then this is fine. And basically what it means that I need to shift the elements right. So what does it mean? What does it mean if I want to shift the elements right? So I can write shift elements right. So what does it mean for the linked list? It means that I need to, so I have the node which is currently positioned by index, so I need to shift it on the right. So it means that I need to basically, so then that would be for the elements D, I would create element node. So this will be new node, and then what will happen here? I said that I will use the following constructor, which has the previous, and the previous would actually be the one which is the previous for the current one. The current one would be the element I add, and then the next one would be the node index we got. Okay, and then for this one we have previous, we have the current element, and and then we have also the next one, which is the node index. And then the last thing what we need to do, also for the previous we also need to change next. So node index next, basically if node index is not null, because it can be null as well. So if node index is previous is if it's not null, because it can also be null, like in case if we talk about the first element. And so then if the previous is not null, then we cannot, because it can be null if we we replace the first element. So previous is null can be null if we talk about first element. So that's why I need to change the next one for the previous one. So if I want to shift the elements right one, it means that the previous for the next one for the previous would be my current element, my current node. So then that will be fine. Okay, we replaced the next one for the previous. Then the current one has the previous, and it has the element. The current element, it has the next element. And so then the last thing what we need to change is we need to change the previous for the next element. If the next element is not indexed, so it means that the previous for the next index would be the current one, the current we add. Maybe this may be a little bit tricky for you, but this is just a thing to follow. Okay, so here you see that, okay, then in this particular case we need to set it as public sector. Yeah, okay. Because we may need to change previous. Yeah, okay, then in this case I set it as public. Because we may need to change the previous line in this case. Okay, so let's see if this works. Let's see if this works. So maybe I will not move fast, but I will add. So let's say I want to add, and yeah, of course, one more thing I forgot is to increment the size, of course. Get elements. Sorry, where's this one? Index. Yeah, of course, we need to increment size in this case. Yeah, if we add a new element, we need to increment size, that's for sure. That's for sure, and let's try it here. Add. So let's say I want to add a position 2. And I want to add the element. Hello, here I am. For example, yeah. So let's see if it does not crash. It does not crash. Okay, it was, oh, yeah, it works fine. Right, so I shifted. Yeah, okay, so it looks fine. Yeah, it looks fine. The element can be added. So let's try one more to add. So let's say position 4. Here I am again. Okay, so the element is added. Okay, so seems that it works fine. Yeah, we can implement some more logic, yeah, if you want, but these are the main ideas of linked list. Yeah, so I just implemented this one for you to understand how the concept of linked list works. Yeah, so we don't use any arrays, we don't use similar structures, we only use the linkages between the nodes, and if we do some adjustments, then we change these linkages. Okay, and in fact, we can work with them as with the arrays, and we don't need to create the arrays. So, do you have any questions about the linked lists?
I have a quick small question regarding Node. So basically, as I understood, Node is like some kind of basket or something where you can put inside different kind of elements, or how would you?
So basically, as I said, the problem is that for the elements, like if you just simply have the elements, like any kind of element, yes, here this T, I mean, it can be string, integer, or any random element we have in C#. The problem is that for these elements, we don't have these parameters stored, these members. They don't have themselves. They don't have these members. They don't have previous. They don't have next. They don't have current. Maybe would not be needed, but they don't have previous and next. But for the linked list, we must have such place where we actually map the object T, and we map the object to the previous node. So basically, the node is to make it simple. The node is actually the element of the linked list. So this is the element of the linked list, and basically inside this element we store the actual element, the value element, the object. So basically it means that if we have the object to be stored inside linked list, we need to put it inside the node, then we have this node, and then this constant. So this is like so we have, let's say the container, or maybe the collection container, when we have the boxes of chocolate, or maybe not boxes, but a bar of chocolate, or maybe the pack of chocolate, and then that this will be just simply the way how we pack the element inside the package. So this will be simply the package where we place our element. Yeah, so like the package where we place the element. And this again, this is needed because the object itself, it does not have the option to store the linkages between the other elements. Yeah, so this is like the place where we can put our object inside, our element inside, and then here we have some additional opportunities. So basically this is the object inside object, which is then needed to apply such linkage. This is what the node is about. But in fact, yeah, we can store, we can only link the nodes. Yeah, we can, because the objects themselves, they don't have such functionality to be linked with each other. That's why we need to use your nodes instead.
Thank you.
Yeah, so this is such additional feature. Any other questions about linked list? Yeah, the question may be why and when we need to use linked list, and why we need to use our array list, for example, or lists. Yeah, so that would be the question we'll discuss next. But about the general structure of linked list, is it clear? Basically the generic linked lists that are implemented similar way. Yeah. So here I just wanted to show you how this looks technically, so how we technically can implement such structure. If I'm not mistaken, at least, I read some programming memes, maybe some programming stories, and yeah, there were some stories about where the programmers had the interviews in companies, and there were the questions about linked lists, how they're implemented. Can you implement it? Can you write the code which implements it, and so on. So maybe there may be such. Not sure about the interviews, because again I had my last interview, like I guess that was a long time ago. It was more than 4 years ago. So yeah, maybe I'm not really familiar with the structure of the interviews nowadays. But maybe there, for programmers, there may be such questions. Maybe, sure. But it's quite technical thing, and it may be relevant. Okay, and maybe before we discuss advantages and disadvantages, let's have a quick look on the. Yeah, maybe I will open a new window of Visual Studio, and then let's also have a quick look on the would look like. So let's maybe have a look on the activity. Guess that was activity 3, where we implemented the array store. Let's have a look. Or maybe you know, maybe okay, maybe I will give you this task a little bit later then. So maybe because this is what you can enhance. Okay, yeah, maybe let's maybe do this as the okay. At this point, I will not do this. Maybe you can then do it yourself as the practical task. Okay, maybe this will be later. But yeah, so let's go back to the list. So basically, what's the point to the list? What's the point of the list? Like every time when we add the elements, we create new array. Yes, so it means that the elements are stored using the array, and every time we add new element, then there's actually the new array created. Yes, so every time. And here we may have the question when to use linked list and when to use list. So then the question is then redirected to the actual structures of linked lists and the array list. What are advantages and disadvantages? So let's take a look on the advantages and disadvantages of linked list. So what's the advantage? The first advantage is that it is quite simple to add new elements technically. I mean, so all the advantages and disadvantages here we look from the technical perspective. So if we want to add the element, what we simply do, we create, in all the cases, we need to create a new node. Yeah, and that will be it. Yeah, so we simply create a new node and change the last element. Yeah, or the first element if needed. That will be it. So we don't do some kind of copies. We don't create new array. We don't copy the existing element from the array. We simply create new element and add the linkage. So this is advantage. This is advantage of linked list comparing to the array list. It is much more simple to add a new element. Yeah, it is much more simple from program point of view, from time point of view, because it takes less time to do it this way, and that we create the element and add the linkage. So this is definitely faster and easier from program point of view. Yeah. So added index also similar way. Yeah, we don't have any loops here. You see, this is also nice. Nice advantage. We don't have any loops. So in theory, if we don't have loops from the programming point of view, it means that it happens in the constant time. Yeah, maybe. So just we'll talk maybe about time complexity a little bit later. But time complexity is an important topic. But if we say roughly, then we can check the number of steps we have. So we have 1 step, 2, 3, 4, 5, 6 steps, or that would be, or 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. Yeah, so we can count these steps. Yeah, if we have, like in this case, when I read the program, I have the number of these steps. Oh, I don't have get node by index. Okay, yeah, if we have get node by index, then it means that I have while loop, which okay, yeah, then at this point, okay, at this point I cannot count because I have get node by index. Okay, so in this case, maybe for add that won't be good case, but for this one, this will definitely be the one we can count. So we have, let's say, one operation, 1, 2, 1, 2, maybe let's count deeper, 2, then when the constructor is called, that would be 3. Yeah, so 1, 2, 3. 1, 2, 3. Add 1, 2, 3, 4. Yeah, so we have 4 steps here, or we have 1, 2, 3, 4, 5. If I'm not mistaken, or yeah, 4, 5, 6, 7. Okay, at least we have the countable number of steps. So at this point, when we write the program, when we read the program, again, I don't know how many elements there are in this list, but I'm sure that there will be the fixed constant number of steps. So it means that this is the time complexity is constant, which is the best, the best, yeah. So if the time complexity is constant, means that this would be, it is the best one. Yeah, so I mean for the large number of elements, this would be the best one. Yeah, because if you, again, but for the arrays, for the array list, then we have the copy of the array, which will take time complexity of n steps. So it means that it's not the complete, it's like all from 1, so it's not constant, it's linear time. So linear, it means that it has n steps at least, yeah, or constant times n steps. Yeah, and times n is because when we go through all the elements. So this would be for the array list. So, and what does it mean? It means that for the adding elements, it is, especially for large number of the elements, it is much more faster to do it, much more efficient to do it using the linked list. Yeah, so add last is the advantage for, like if you want to add at the end of the collection, this would be the advantage for the linked list. Same for the remove last. Yeah, so we have 1, 2, 3 steps, so it's constant number of steps. If we remove the last element from the array list, then again we need to copy the elements and create new array. So this will take at least n number of steps, again, because we need to go through all the elements of the collection. So then again, we have advantage when we add the new element and when we remove the element. Where are the disadvantages? So where do you see any disadvantages here? The question to you. So where we see that something is, maybe something could be better. Cases. So we see disadvantage, for example, here, when we want to get not by index. Why? Because again, what we have for the arrays, and same for the array lists, for the lists, what we how we can get the element by index. We simply access directly. So when we want to get the, let's say, the array, we want to get the element by index.
We need additional methods for some.
I mean the methods, the existence of the methods is not the problem. The problem is what is inside the method, because methods, they are just simply the place where we store the logic. Yeah, so like if we have more methods, this is never the problem. The problem is what you have inside the methods. Yeah, and so from the performance point of view, usually the key problem is when we have lots of loops. Yeah, and if we have inner loops, it means that loop inside loop. So again, because for constant steps, again, I can count these steps like here I have 1, 2, 3. So I have 3 steps. Again, there may be some complicities, technical complicities when like different operations is done, but in general, I can say that I have 3 steps. Yeah, so roughly I can say I have three steps needed for remove lasts. So this is the constant number of steps. But if I have the loop, like here, I don't, like when I read the program, I don't know how many steps I will need to. So it means that I have first step, second, third, fifth, and then the loop repeats. So it will be 6, 7, 8, 9, 10, and so on and so on. So in this case, you see that if we have the loops, then it takes much more steps. Yeah, much more steps to be executed. and this is what they call time complexity. When we have, the more loops we have, the time complexity is larger. Yeah, we will talk later about the time complexity a little bit, but the point is, when we have the loops, the more loops we have, the more time the program needs to execute. The more time the program needs to execute. So yeah, because I mean the methods themselves is not the problem. Yeah, when I write the method, it's just simply the place where I put the logic. Yeah, if you have more methods, then it's never the problem. Usually, it's never the problem. But the problem is what is stored inside the methods, and the key problem is the loops. And so again, for the arrays, I just simply, if I have the array or the array list, I can, yeah, so just a dummy code, yeah, I'll write it this way. So for the arrays, I can access the index I have, and I directly access the element. So this is one step, right? So because I directly access the element of the array, yeah, so I can assign the element or I can get the element. Yeah, so this is one step, only one step, but you see what happens for the linked list. I don't have the indexes. I mean, like here I have the first element, so it means that I need to navigate through all the elements. I have to find, let's say, the second element and the third element. So it means that I need to go from the first, I need to go next, and then I can count and get the third element. So get by index definitely requires more steps. To read the element, it definitely read by index, it definitely requires more steps. See, because we have the while loop here, and I have no idea how many iterations there will be. Like if we have thousands of the elements inside the collection, and then I want to access the element 921, then this loop needs to be, and then this loop will iterate. What did I say? 920 times, 21 times. Yeah, so it is much more than one step if we access the elements, access the element in the array. Yeah. So yeah, so this is the disadvantage of the linked list. Yeah, if we want to get the element by index. So this is the key disadvantage. And if we want to add the element at index, so again we need to read the element by index. So it also requires us to go through all the elements up to this index to find it. And so this is disadvantage. What else we have? Moments. Let me quickly check if I have not. If I have not missed anything. So let me quickly check. Yeah, okay, get by index. This is what I said. Okay, yeah, so add the elements. This would be, yeah, remove by index. This would take a same number of steps. But yeah, I would say get element by index. This would be the worst, and I would say maybe the only disadvantage comparing to the array with list. Yeah. Because we need to go through all the elements. What are the advantages? Advantages, as I said here, is to add the elements. Yeah, because when we add the element, it simply takes like the constant number of steps. And yeah. So yeah, this is the point. So when you have lots of elements and you constantly add them, like it's not just simply you have, let's say, 10, I add 10,000 elements at once, and then maybe I can, I will only read them. Then you can use list. But if you want to add the elements constantly, like you have the loops where you want to add thousands elements inside the loop. So like, let's say you have the loop which will add the elements to the collections, and you expect there to be thousands of the elements. Then in this case, it's better to use linked list. Yeah, because if you constantly add the elements, you spend less time here. But for the array lists, yeah, for the list based on the arrays, you need to, like, every time when you add the element, you need to copy the existing array to the new array, yeah, copy all the elements, then create new array, add the element at the end, so it definitely takes time. Okay, so, but we'll talk about time complexity a little bit later. Do you have any questions? No. Okay, if there are no questions, then we can maybe go through the presentation a little bit next. So we talked about the collection framework, talked about the operations. Then, yeah, what I said about the implementation. So again, remember, as I said, collections. It's collections on with the name of the interface. Yeah, in fact, there are the real classes at the end of the day which represent the collection. So again, different type of collection implementations we can have. So first we say we have indexables. So these are the list. Yeah. So array list and linked list. So it means that we can count these elements. Like we can have the first element, the last element, first, second, third, fourth, and so on. And so they are countable, indexable. We can count them and index each element. Yeah, so, and for such case, we can use array list and list, and also linked list. Then the next type of the collections are the sorted list and dictionary. So these have the map between key and value. So it means that there is the key and there is the value. The key should be unique. Yes. So let's say have some kind of table with the elements 1, 2, 3, 4, 5, 6, 7, 9, 10, for example. And then for each number, there is the, for example, name of the person assigned. So that would be, yes. So again, maybe just small Excel example. Let me open my Excel. Yes, so say 1, 2, 3, 4, 5, yeah, so or something like that. So let's say that would be name 1, name 2, and then again I can repeat because the values are not unique. They can be not unique, but yeah, so it means that for one map, so here I have the map between key and value. Maybe I can just write key and value. Yeah, and then for the key should be unique, value can be not unique. Yeah, and then for each key I have the value assigned. So it means that when I provide the key, I can get the value. Yeah, so say I provide 3, I get name 1. I provide 1, I get name 1. I provide 4, I get name 2. I provide 2, get name 2, and so on. Yeah, so this is the idea of key and value. So as see, for this particular case, I can do something similar to what we just done with the node. So here maybe we will take a look on it other day. But so here I have the node. Here the node have the current elements implementing. But in theory, I can also have the some kind of node which was, say, node key value. So that would be key value type, which has the key and which has the value. And so it's yeah, which has the key and which has the value. So that would be public key, oh sorry, public key get set and the value. So also that would look the same way. Yeah, so again, I can use the node and then I can store the values. So we'll take a look on it next time. But yeah, it can also be implemented using the nodes. And then we also have the hash tables. Hash tables, they also implement a dictionary, so they have the mapping between key and value, but they have this hashed structure. So it means that yeah, we'll talk about hashing Iterator. For my group, I guess we discussed this during my course, but we can repeat it. That's not a problem. Yeah, so basically, hash structure, hash table, and hash set, they use the hashing. Yeah, they use the hashed function. Yeah, to basically store the elements, to map the elements, to store them. Hash values, hash tables are mostly needed for the large tables, for the large amount of entries. But yeah, we'll talk about them a little bit later. So what kind of characteristics we can have for the collection? So the collection can be ordered. Yeah, so it means that like they can be indexed. Yeah, so they can be stored and accessed in a specific order. Yeah, we can order them. And then there are the sort. Yes, we can provide the order type. So like this is simply for the table. We have the table, so I can order by value, data sort. Oh, moment, I guess I need to do it this way. Yeah. So then I can order by A to Z by, say, the value. And then it's this order table by value. For the sorted is more specific because the sorted actually requires one specific column or the key, yeah, to be sorted. So we'll talk about the advantages and disadvantages of sorted and unsorted collections. But the thing is that these collections are sorted by default. I mean, it's not like we have the random collection, then we order it, and now we get a sorted collection. Sorted collections, they are sorted by default, so it means that at every time the collection exists, it cannot be not sorted. It should always be sorted. Yeah, so this is about sorted collections. Indexed means that they can be indexed like 0, 1, 2, 3, 4, 5, 6, 7. Yeah, so they have numbers because hash entries, hash tables have they never have numbers, they never have indexes. Unique means that unique collections means that only unique elements can be added, so we cannot have duplicates there. And same example we had for the linked list, the nodes should be unique, so we cannot store multiple nodes, same nodes inside one collection. Okay, so then let's have a quick look on the lists. So for the list representation, remember that we have the lists, how they are linked, how they are stored. That's the different portion we're discussing, but the thing is that they have the elements, the value, and they have the index. So basically, we can say that this is the map between index and value in some way. So we can add the elements to the list, and then basically they will be added one by one, and each of them has will have the index. In addition, we can also add range, and so this will add multiple elements to the collection. Then we can also insert element at the position we are looking for. We pass here. So, and one more example is the list, and yeah, so we add the elements, so they will be again added one by one, and yeah, so we can simply loop through all the elements if needed. Yeah. So, but yeah, I mean, we discussed all these cases except add range. We can also add the part of one collection inside another collection. So that's also possible to merge the collections. So this is also possible when we add. Yeah, we can add range. Okay, do you have any questions about the lists? Okay, then I think we can maybe then finish for today. And next time we can, tomorrow, we can then start discussing the maps. Okay, so if you don't have any questions, then let me, then we can close the session. I will push the changes to GitHub, and then see you all tomorrow then. Okay. Thank you very much, and see you tomorrow.
Thank you. Bye bye.
Thank you. Goodbye.
Bye.